Chapter 2 on limits. We'll also be talking about continuity. This is where we really start to develop the ideas of calculus. Everything chapter 1 is pre-calc stuff. And when we get into talking about limits, the point of talking about limits is that, so in chapter 3, we can introduce the concept of the derivative, which is the most important object in Calculus 1. And so before we get into a discussion of formally what limits are and how we compute them and stuff like that, we're going to start off with a section here, section 2.1. It's talking about tangent lines, rates of change. It's really giving you the idea of a limit, which, in terms of these rates of change. And so the first thing that we want to think about has to do with average speed. So if you are driving your car along the road, if you have a car, you will have some kind of speedometer that will say, at this moment, you're going 40 miles an hour down the road. And that's an instantaneous speed. Before we talk about instantaneous speeds, let's think about how we can compute average speeds. So if you drive along and you travel 120 miles in 2 hours, on average, 120 divided by 2 is 60 miles per hour. On average, you are going 60 miles an hour. Now, at that point, you may have been going faster than 60 miles an hour. At other points, you may have been going slower than 60 miles an hour. But on average, you were going 60 miles an hour. And so this right here, this idea of average speed, is going to be our first thing that we're going to discuss here. So average speed on the interval from t1 to t2, ft is measuring distance traveled at time t. Starting off with at t is 0 seconds, you've gone a distance of 0. It's the distance traveled divided by the elapsed time, and you can find that f of t2 minus f of t1 divided by t2 minus t1. Our problems that we're first going to think about in this section have to do with what's called free fall, which is, imagine that we have a cliff here and we have some rock and we just drop it, and so it starts to fall. And so as it turns out, ignoring air resistance and stuff like that, a pretty good approximation to the position here. So let's say let's say y is equal to 0 is where we let go, and this is increasing y. So we're measuring the distance traveled, the distance fallen. The formula is going to be y is equal to 16t squared, measured in feet. So this formula goes back to Galileo in the late 1500s. I mean, he wasn't using feet as his measurement, but he had worked out the basic ideas here. So after 1 second, your rock has fallen about 16 times 1 squared is 16 feet. It's 16 feet lower than it was before. After 2 seconds, 16 times 2 squared, 16 times 4, 64 feet. Your rock has fallen 64 feet. And it will continue moving like this until it hits the ground.